Welcome to the video lecture series on principles of compiler design. In today's video lecture, we will be learning about the way of constructing a YACC. We will be writing a set of rules for recognizing an expression, arithmetic expression. But before stepping inside the coding here, we will be understanding the association between the LEX and YACC tool. So LEX actually supplies an input for YACC. So YACC cannot function without LEX. In principles of compiler design, we have learned that LEX used to supply the tokens to the YACC. So finally, the YACC will be, after if everything goes right, then it will be framing a parse tree. So this is how actually YACC functions. If it is not adhering to the rules, then obviously it will generate syntax error will be generated. Now, first we will, this LEX and YACC actually functions in coordination with each other. Now, we will first write the LEX tool rules here. So, in this LEX tool rule, I am going to write where we are going to recognize a number. So, initially, a number should start with a digit, and it should actually subsequently have, it should be followed by digits. Now, I am writing a number from 1 to 9 plus. So, now it means that from 1 to 9, you can have any digits here. So, I am just deliberately skipping 0 because first digit cannot be 0. So, in this case, actually, I am not using 0 here. So, that is why I am deliberately skipping. Apart from 0, you can use anything. So, this is my own rule I am writing here. You can also include from 0 to 9. So, 1 to 9 plus means you can use any digit from 1 to 9 in one or more number of times. Now, this YY is called as a lexical value. Now, and whenever input is given, even if you give a number, that will be considered as a string. So that string has to be converted to an integer. So that's why we are using a function called as ATOI. ASCII to integer is a short. ASCII to integer is called as ATOI. YY text, if anything matches the pattern, that is called as YY text. And if everything goes right, then we are returning a token called as number. Now, and when we press slash n, when we press a new line character, obviously we are going to return a value. And if there is not any match here, dot means any character, apart from any character is given, simply we are returning the first character to the parser here. Now, this two consecutive percentage symbols is a location where you are supposed to write the rules here. So, this is called as a rule section, and we need a wrapper. So, for having a wrapper, we are using integer YY wrap. YY wrap is a built-in function which actually makes the wrapper for this lexical code here. And since it is returning an integer value, we are returning 1 here. So, now this is called as a lex file. Now, I have named this file as plex. Now, I will save this file. Save this file. Once I save this, now I will go and run it now. So, command prompt, it is in E colon, and I go to my own folder called as lexi folder. Then I run it as flux, and the file name is called as plex.l. Now, I don't get any error, so that means my rule is correct. Now, after this, we will go and construct a YACC tool. We will write the YACC rules here. So, to write the YACC rule, I am having a rule called as parser here. So, this is called as a file called as parser. Parser, I am simply including C, for C actually, so for C support I am using hash include stdio.h, and this flag value is not mandatory. So, when flag value is 0, that means everything is going right. When flag value is 1, there is a syntax error, and obviously we have to handle that error. Now, in LEX tool, we have actually returned a specific token that is called as a number, and we have to define here with the help of a keyword called as token. When you use percentage token, that means we say that we have a token and the token is called as number. And after this, we have to implement a set of expressions here. Expression can hold different operators. In this case, actually, we are using arithmetic expressions here. So, I will actually stop here with only arithmetic expressions, star, slash, plus or minus, and open brackets and close brackets. Now, we are writing this keyword called as left, percentage left. Left is means it is called as left associative. Okay. Now, when I say left, here I am using two arithmetic operators called as plus and minus. If an expression have plus and minus, in the same, in the same expression you have plus and minus, normally it will be evaluating from the left onwards. That means this left says these operators are left associative. Now, understand that whenever we have an element on the bottom of this set of rules here. So first rule is actually we are writing the rule for star, the second rule is slash, and third rule is plus and minus. That means the bottom, the last rule will have the highest precedence. That means plus and minus will have the highest precedence over star, because I have framed the rules like that. Now we will just, when we just try to execute, we can easily understand that. Now see here, now I am going to implement this rule called as E tends to E plus E, then bar E star E, then we will have E tends to E slash E, or we will also have E tends to open brackets and close brackets. So this is the grammar which we are going to implement it here. So I am going to perform all the arithmetic operations including plus, minus. So this will also will be in picture, E minus E. So all this entire grammar we are going to implement with the help of this YACC tool. Now this grammar will be taken into account and will be implemented one by one. Now first we will just give input. Input tends to E. So this is similar to input colon E means. So this statement input colon E means we are just giving it as, we are giving it as input E. So this is the grammar. Okay. So first I define input is equal to E, then I define E tends to E plus E, E star E, so on and so forth. Okay. Now listen carefully. When input is E, now E is going to hold the result here. So if the result will be actually stored in this $2. This is actually a default delimiter where it holds the results. Consecutive dollars will actually hold the result. So once if you are getting evaluated to E, then actually it prints this. So I am simply using print of result percentage D, because the result is going to have an integer value, so percentage D, and the result will be holded by this consecutive dollar symbol and simply return 0. Now I am going to define what is meant by E. E means it is an expression. E can be defined as E plus E. Okay, if this is the expression, what I have to do? So the left side E is going to hold the result. So left side E is going to hold the result, means result will be represented as consecutive $2. Okay, the first E is called as $1, and the second third E, the second E is called as $3. So during this intervening case, you have plus is called as $2. So that is the operation here. And similarly, this case falls for everything. So for this E, it is called as $1, and this E is $3, and this minus is actually $2. So $2 is actually used to evaluate an expression. And when we come over here, for all these expressions, we have 3 elements on the right side. But when we come here, in this case, we have 3 elements, but the result will not be stored in the first element. The first element is actually called as open brackets, and the third element is close brackets. We are not going to have the result in open or close brackets, but we will be having the result in E here. So this E is called as $1. It is called as $1. So here I think it should be written as $2. E should be written as $2. This E should be written as $2. So on and so forth, we will be having like this. Now the final thing is called as number. Number is having only one element, so I am simply writing it as $1. Okay. So this is $1, and this is $3, and this is $2. So E is having the result, so I am simply writing it as $2. So on and so forth. Okay. Now finally, we will end up with this. Now this vertical bars is used as a separator for grammars. It is called as an alternative version of a grammar. So if you have the first grammar, if first grammar does not match, we go for the second grammar, and so on and so forth. So this is called as an alternative version for the grammar. Okay. alternative choices for grammar. Finally, we will go here and we will enter an expression. So when you use YY parse, actually it will take the input as well as it will process the rules here. So flag is equal to 0, everything is valid. And if some error occurs, we are writing a separate code called as YY error. In that we have a pointer value called as S. And if something goes wrong, then we will simply print of invalid. So it will return a value called as 0. So this is how actually a parse tree will be constructed. A parse tool is constructed, or a parse code is constructed in this way. Now we will save this file and we will run this. Now I will run this here. This is called as parser here. So how to run it? So we will have bison. So we will run /t/d, and then name is called as parser.y. So now you can see here in parser.y in lex here, you see a new file called as parser.tab. Now you can see that the time is 7, today's date is 7, and then it is 1957, 7:57, it has been getting generated. So this header file is automatically generated when the lex file, YACC file does not have any error. Now this parser tab.h file has to be included in the lex file. Now what we have to do here is we will go here to the lex file and we will include this. So that's how I will. Now this is not the file here, I will just include it. So here I have to include this file. So hash include then parser.tab.h, because all the definitions associated with this lex will be incorporated inside this header file. So we have to include this file. So once we include this, once again we will compile this flex file. So flux.plex, everything is right. Once again I will do it for bison also, we will do it for the same. Now what we are going to do here is, now we have to take two files into consideration. One is called as lex.yy.c, which is available here. See, lex.yy.c, this is just now created, and then parser.tab.c. These two files has to be taken into consideration while we generate an output file. Now I will just create it. So how to create it? GCC lex.yy.c, then parser.tab.c, then I generate an output file called as -o. O is called as an output file, and I just write it as my parser. My parser is the name of the my file here. So it will throw some warning here, just ignore the warning. So we are not concerned about the warning. Now we will simply write my parser. So when I run it, I will give an expression called as 3 plus 4. Now you know that you are getting a value called as 7. But see here, when I give 3 plus 4 star 5, okay, obviously the result should be 4 into 5 should be 20, 20 plus 3 into 23, okay. But here you will get a result in a different way. See here, okay, now sorry, it has to be executed. Now I give 3 plus 4 into 5. Now the result should be 23, but instead of that you are getting an answer called as 35. Why? Because plus has a higher precedence over star. So first what it happens here is 3 and 4 are added, it will be 7, and then 7 is multiplied with 5, so you get a result called as 35. Now since addition have a highest precedence over star, we are getting this answer. But how to change this? So how to go to the conventional way? So to change this, I have to make the change in the rule. So in parser, I will take this star here, star, so control X. Now I will just give it here. Okay. Now star has higher precedence than plus, since it is actually on the bottom of plus here. Okay. So plus is actually preceding here and star is following that. So as per the YACC rules, whatever the operator which is following has the highest precedence. So star is having the higher precedence now. So we will just save this file, and once again we will try to execute the same expression. So once again rerun this procedure now. So Bison, now we will take this file. So warning has been thrown. Now my parser. So 3 plus 4 star 5. Now you are getting an answer called as 23. So this is the way how to evaluate that. So you can change this rule in any order and you can substitute that. Say for example, I can also do like this. My parser, I give an expression called as 2 plus 4 star 3. So I give like this. Now you get an answer called as 14. Okay. So because star has a higher precedence, and this now we will change in different order. Now see here, I have so 3 plus 4 star 5. Now we will get an answer called as 35. Why? Because since these brackets have a higher precedence over star here, so 3 plus 4 will be evaluated first and then star will be evaluated next. So this is how actually it is getting done. So that's about the way of writing the YACC tools here, YACC rules here. So thanks for watching the video. Have a good day.